Today, we can do the last section in chapter 5, and that is LRC circuits. And if you look at your notes, I gave you a beautiful picture of this LRC circuit. I tried to duplicate it. I suck at drawing. You know this. Oh well. So here's the LRC circuit where your I is current. It's the current. And it's measured in amps. And E is your voltage, and that's measured in volts. And L is inductance, which is measured in henries. R is resistance. Measured in ohms. C is for capacitance. Measured in farads. Q is going to be the charge on the capacitance, and it's measured in coulombs. And then T is time, and it's measured in seconds. All right, so there's our circuit. Now, this is an electromotive force. The E is inductance is going to oppose any change in the existing current. R is going to oppose the flow of the current. What else? This electromotive force E, this force is going to push the flow of particles. This is now a variable source, right? Showing it like that means it's a variable source versus we had done, we've done circuits before, but it was with a battery. And so when you had, before, problems we did before, we had symbol like that with a plus and then a minus, and that was a battery, which was constant. So that's a big difference between these this time. And then, so remember that we had that symbol instead of this circle thing before. And then what we want to do is we've got, how does the voltage drop? So the voltage drops are a couple of things. So the change in the voltage due to inductance is going to be Li prime. The change in voltage from the resistance is going to be Ri. And the change in voltage due to capacitance is going to be 1 over C times Q. So here's our voltage drops. And this is where your I, which is your current, the current is the change in the charge over time. And one of Kirchhoff's laws says that the sum of these voltage drops must be equal to the applied voltage. And so when we add up these guys, so by one of Kirchhoff's laws, we've got delta V with respect to L plus delta V with respect to R plus delta V with respect to C. The sum of these voltage drops must be equal to the applied voltage, which was E of T. And so replacing all of these guys, then that means that the equation we're going to use is Li prime plus Ri plus 1 over CQ is equal to E of T. That's the equation we're going to use. And we have initial conditions that the charge at 0 is 0, and the current at 0 is 0. So think of 0 as right before they close that switch, right? We've got the switch there open, and then at 0, and then when it closes, then the current starts flowing. Okay, so let's do an example. I give you all the information? I think so. We're going to find the current as a function of time. So find the current as a function of time. For the following LRC circuits, if the switch is closed at t equals 0. Okay, and the first one they gave us that the inductance is 0.2 henries, that the resistance is 2 ohms, that there's no C, there's no capacitance, and the voltage is 4 volts. All right, and then keep in mind we also have that the current at 0 is 0. Yeah, and then there's no C. Okay, so we're going to use this equation from one of Kirchhoff's laws that says, all right, Li prime plus Ri plus 1 over C times Q is equal to E. And so L is 0.2, so we'll have 0.2 times I prime plus resistance is 2, so 2I. There's no C, so we just don't even include that, and then equals 4. So there's our equation, and we're wanting to find I. And so I'm going to get rid of this fraction by multiplying both sides of the equation by 5. This makes my life easier, right? Plus, I really want to have no coefficient on I prime. And so that'll get me I prime plus 10I is equal to 20. And this is a differential equation that you know how to solve. This is d plus 10 acting on I is equal to 20. And how we solved this was we started off with the associated homogeneous solution. So the homogeneous equation would be d plus 10 acting on I is equal to 0, where your R is negative 10. And so the homogeneous solution would be C1e to the negative 10t. Now, we find the annihilator of 20. Well, it's just a constant, so that's nice. You just take the first derivative of a constant and it'll get you 0. So the annihilator of 20 is Q of D, which would just be D. And that gives you R is 0, and so your particular solution for I would be C1e to the 0t. Well, that's just C1. You know? And we don't have any repeats happening in Q of D with P of D, right? So we go and go, okay, the particular solution is C1. I'm going to change it to A. Remember, I can actually find this value. That's what I'm going to do. I'm going to say that's equal to A. And then the derivative of this particular is 0. And when I put those together and plug it into my I prime plus 10I equals 20, well, that'll give you 0 plus 10A equals 20. And so your A ends up just being 2, which that just gives us that the particular solution is just 2. All right, so then our equation will now be, you take that homogeneous plus the particular, right? And we've got C1 e to the negative 10t plus 2. But they gave us this initial condition of I of 0 is equal to 0. So we can solve for C1 as well. So 0 is equal to C1 e to the 0 plus 2. It's like negative 10 times 0, right? So you end up getting 0. And so that ends up giving you that C1 must equal, subtracting the 2, negative 2. And so we are now able to say, we can find that the current as a function of time is C1, which was negative 2, times e to the negative 10t, and then plus 2. There's our current as a function of time. As a side note, the homogeneous solution, right, was what we call the transient current. And the particular solution is called the steady state current. All right. Let's do another example. And this time we're going to have a scene. All right, example 2. So same directions, we're going to find the current as a function of time, given that your inductance is 0.5 henries, your resistance is 2 ohms, your capacitance this time is 0.1 farads, and your voltage is a function of time this time, 2 times sine of 4t. And we do have, we have also that your current at 0 is 0. Okay, so I'm plugging this into my equation, Li prime plus Ri plus 1 over CQ is equal to E. So this would be a 0.5 I prime plus 2I plus 1 over 0.1 Q, and that's equal to 2 sine of 4t. I'm going to make this first coefficient 1 by multiplying both sides of the equation by 2, and that'll give me I prime plus 4I plus 20Q is equal to 4 times sine of 4t. Since 2 divided by 0.1 will give you 20. All right, now remember that I is dq dt. Yeah, and so let's differentiate with respect to t. All right, so I'm going to take this guy and do d dt. Because right now I've got i's and I've got q's, but I is dq dt. So by doing this, we can get everything in terms of i's and t's and not have this extra variable in there, right? So derivative of I prime would be I double prime. Derivative of I is I prime. And then ddt of q would be dq dt, but that's what I is. So 20I. And then the derivative of sine of 4t would be cosine of 4t, but then times 4. So you end up with a 16 times cosine of 4t due to chain rule. Okay, so now I've got a differential equation that you know how to solve. This is d squared plus 4d plus 20 acting on I is equal to 16 cosine of 4t. So we start off by finding the associated homogeneous, and that would be d squared plus 4d plus 20 acting on I equal to 0. All right, well, so you're solving for this guy equaling 0, right? And you can't factor it. There's not two numbers that multiply to 20 but add to 4, but it's an easy complete the square problem. And that would be 4 divided by 2 is 2. 2 squared is 4, so I'm adding 4 to both sides, which gives me an r plus 2 quantity squared is equal to negative 16. And so that will give you an r equals negative 2 plus or minus 4I. So remember how you handle complex solutions, right? This is your A is negative 2 this time, and your B is 4. And so your homogeneous solution would be C1 e to the AT, so negative 2t, times cosine of BT, plus C2 e to the negative 2t times sine of BT. Hopefully you remember that's how you find the, when you've got complex solutions, it's those two guys and then a linear combination of the two. Okay, so now we've got our homogeneous solution. Now we need to find the annihilator. The annihilator. Let's find the annihilator of 16 cosine of 4t. And that is d squared plus 16. You can confirm it yourself if you need to. All right, so that means that if I've got r squared plus 16 equals 0, find my roots, then r would equal plus or minus 4I, which means your A is 0 and your B is 4. And so the particular solution would be C1 e to the 0, which is just 1, right? Cosine of 4t plus C2 e to the 0 times sine of 4t. Now, which just means, I mean, technically it was a 0t, write that, but you're plugging in a 0 into that A for A and then a 4 into the B. I'm going to change my C1s to A's and my C2 to a B. You know? So IP, I'm going to call it A times cosine of 4t plus B times sine of 4t. So then I have to plug this into my equation, so I need the first derivative and the second derivative. So first derivative of the particular would be negative sine of 4t, but then times 4, so a negative 4a sine of 4t, and then plus derivative of sine would be cosine, but then chain rule says times 4, so a 4b cosine of 4t. And then second derivative of particular derivative of sine would be cosine, but then times 4, so a negative 16a cosine of 4t. Derivative of cosine is negative sine, but then times 4 also, so a minus 16b sine of 4t. Yeah. All right, we're going to take this guy and we're going to substitute it into my equation of I double prime plus 4I prime plus 20I is equal to 16 cosine of 4t. All right, so I'm going to come down over here and I would have your second derivative is negative 16a cosine of 4t minus 16b sine of 4t. And then we have plus 4 times I prime, which is negative 4a sine of 4t plus 4b cosine of 4t. And then plus 20 times I, and of course I'm going to run out of room, so I'm going to come over here, plus 20 times I, which was a cosine of 4t, plus b times sine of 4t, and all of that's equal to the 16 cosine of 4t. Okay, so what you need to do is equate coefficients. So what I'm going to do is I've got terms with cosine of 4t in them, and I have terms with sine of 4t. So I'm going to factor those out so that I can equate my coefficients. So if I factor out a cosine of 4t, what will I have? I would have a negative 16a. That's a sine. That's a sine. Okay, so I have a cosine here, but I would have multiplied by 4. So it would be a 4 times 4b, so a plus 16b. And then I would multiply the 20 times the a cosine, so plus 20a. And then I'm going to factor out a sine, because my other terms are a sine of 4t. Okay, and I would have a negative 16b. This I would have had a 4 times negative 4 times a, so a negative 16a. That's cosine, and then a 20 times b. And that's equal to 16 cosine of 4t. Yeah. All right, I do have a cosine of 4t, right? And my coefficient is 16, which means that this guy is the coefficient on cosine of 4t. This must equal 16. And then because I don't have a sine of 4t on the right-hand side, that means the coefficient on sine of 4t on the right-hand side must be 0. So now I've got two equations, two unknowns. Yeah, this equation would be what? 4a plus 16b is equal to 16. And this would be what? 4b, so minus 16a plus 4b must equal 0. I mean, you could definitely do a, yeah, let's go multiply the first guy by what? 4, or we could do substitution. This one's 0. Yeah, let's do that. Okay. So I'm not going to do linear combination. I'm just going to go, oh, look, this guy, if I solve for b, that means b would be, you would add the 16a and then divide by 4. So b is actually equal to 4 times a. All right, now I'm going to plug it into this guy, which will give me a 4a plus 16 times 4a is equal to 16, which is that 4, 64, so 68a equals 16, and so a is equal to 16 over 68, which 4 goes into both, 4 over 17. And so then b is equal to 4 times a, so 4 times 4 over 17, which will give you 16 over 17. So your particular solution is a, which we said was 4 over 17, times cosine of 4t plus b, which we said was 16 over 17, times sine of 4t. Okay, so our current as a function of time is going to be the homogeneous solution, which was C1 e to the negative 2t times cosine of 4t plus C2 e to the negative 2t times sine of 4t. That was the homogeneous solution. And then plus my particular 4 over 17 cosine of 4t plus 16 over 17 sine of 4t. Now, they gave us this initial condition of that when t is 0, you've got a current of 0, which means that I'm going to have 0 equals C1 times e to the 0 is 1, cosine of 0 is 1, plus C2 times e to the 0 is 1. Sine of 0, though, is 0, plus 4 over 17 times cosine of 0 is 1, plus 16 over 17, sine of 0 is 0. And so you're able to solve for, like, bye-bye, bye-bye, subtract the 4 over 17, and your C1 is equal to a negative 4 over 17. Now we still got to find C2, and to do that, we've got to take the derivative of I. So let's do that. So to find C2, we're going to find the derivative of I. All right, we got a bunch of product rules happening, right? So I'm going to treat, on this first guy, I'll treat C1 e to the negative 2t as the first term, and then this one as the second. And so that you'll have a derivative of the first would be a negative 2 times C1 e to the negative 2 times the second, plus the first guy times the derivative of the second. Well, derivative of the second would be a negative 4 sine of 4t. So I'm going to just fix that little sign. So it'll be a minus 4 C1 e to the negative 2t times sine of 4t. Derivative of 4 over, oh, I skipped over this whole term. Okay, got to do the same thing, but with this guy. I'll do the same thing. So I'm going to treat C2 e to the negative 2t as one term, and then sine of 4t as the second term. And so I've got derivative of the first would be a negative 2 C2 e to the negative 2t, just times the second one, and then plus derivative of sine of 4t would be cosine of 4t, but times 4. So it'll be I ran out of room, so I'm going to come all over here. 4 C2 e to the negative 2t times cosine of 4t. Now, make sure I didn't make any errors, because I don't have you guys to say, Mrs. Bright, are you sure? I'm not seeing any, hopefully. All right, then derivative of 4 over 17 cosine of 4t. Derivative of cosine is negative sine, so this ends up being a negative 4 times 4 over 17, so a negative 16 over 17 sine of 4t. And then derivative of sine would be cosine, and then times another 4, so plus 64 over 17 cosine of 4t. All right, then plugging in that the derivative at 0 is 0 means I would have, we'd have 0 equals, plugging in a 0 into my t's here, would be a negative 2c 1 times 1 times 1, and then a minus 4C1 times 1, but then times 0. Here, oh, I got another sign, so that's going to be another 0. I don't bother plugging it in. This guy would be plus 4C2 times 1. This one would be a sign, so that's a minus 0, and then a plus 64 over 17 times 1. So what does that give me? That gives me a negative 2C1, bye-bye, plus 4C2 plus 64 over 17. And we can plug in C1 now and solve for C2. Take this C1 and plug it in over here. And you have a 0 equals negative 2 times negative 4 over 17 plus 4C2 plus 64 over 17. You end up getting that C2 equals negative 18 over 17. 8 over 17, 72 over 17, 72 divided by 4. Perfect. There you go. Okay. And so we can plug these in now, and then we will be done. Your current as a function of time was C1, which we said was negative 4 over 17, e to the negative 2t cosine of 4t, plus, I don't have it on the same screen. Can I get it on the same screen? There we go. Okay, that's what I'm plugging in. Plus C2 times these guys, and C2 we said was negative 18 over 17, and then e to the negative 2t sine of 4t, and then plus your particular. So plus 4 over 17 cosine of 4t plus 16 over 17 sine of 4t. There we go. That's it. There you go. Nicey, nicey. Not too shabby. And again, I'll just point out the homogeneous part, which was these first two terms. That's your transient current. And the last two terms coming from the particular are the steady state current. All right, there we go. There's section 10. Okay, I hope you all have a fabulous day.